Think math.
Getting close is a vague thing to say. How close counts as close? And from when? One person is happy with 2 decimal places. Another insists on 1 part in a million. If the standard changes from person to person, it is not mathematics. So mathematics hands the standard over to you. You choose the band. Make it as narrow as you like. I will name the place where the list moves inside it. From that place on, every term is inside, and none of them ever leaves again. If I can answer whatever band you bring, then we say the list closes in. Let us actually do it, with 2 plus 1 over n. Say you set the width at a tenth. 1 over n drops below a tenth once n passes 10, so the 11th place does it. Narrow it to a thousandth, and the answer is the 1001st place. Ask for 1 part in a million, and I can still answer. When an answer always exists, we say the list converges to 2. Why must it be any band? If 1 band were enough, this list would pass 2. It swings between 1.95 and 2.05. A band of width 1/10 holds every single term from the very start. But narrow the width to 100th, and not 1 term is inside. So the promise has to hold for every band, not for 1. Now put the promise into symbols. The width of the band is epsilon, and the place I name is n. Saying the gap between a term and the limit is smaller than epsilon means the term is inside the band. And saying it holds at every place from n onward means everything after that. For every epsilon, there is such an n. That single line is the definition of a limit. A vague phrase has become a sentence you can check. To sum up, a vague phrase has been traded for a band that someone else chooses. They set the band, and I name the place where the list moves inside. It has to work for every band, not merely for 1. That is how a limit stops being a feeling and becomes a promise you can test. Next time, we use this definition to pin down a famous value. A sip of math, every day, here at Think Math.